Hi, today we would like to be seeing this coding problem, smallest difference pair. So in this problem, we have been given two lists such that we need to find a pair that makes the smallest difference that is a pair. Okay, so this is the list one, list two, and 11 and 8 is the answer for this. So it can be anything from 11 and 8 or we can take the absolute difference, so it's not like the first one should be less or second one should be less while making the difference. It's the absolute difference when I say the smallest difference. Okay, so how to approach this kind of problem? So basically a naive method of solving this is just creating two for loops and checking all the possible combinations. Then this will run for the outer loop will run for m times, and the inner loop will run for n times. So it is of complexity of big O of mn, because the two arrays need not to be equal, but in this case it became equal. So if the two lists are different, so it is of big O of mn. If the lists are of same length, it is of big O of n square, where n is the length of the input array. Okay, so still we can do better than this and more efficient way, such that using pointers. So what we can do is we can iterate. We can take two pointers. Uh, One pointer starts with the first elements of the each list, like this and this one, and we can check if the left pointer or the first pointer element is lesser than the right point, the second pointer element. So you mean, mm, you can increase this number, this pointer. So I will explain with a little example. Say for example, if we have taken these two values while computation. So say for example 11 and 235. So what is this? 11 less than 235. So 235 is bigger number. And say for example we will get some difference by subtracting these two numbers. We want to go further and continue whether and check, is this the lowest difference that we can get. So we can move this 11 to 2. One more thing here is, so we need to sort these lists beforehand, like 1 2 3 5 11, for using this technique. 8 8 19 23 127 235. Say we have taken these two elements. Say for example 5 less than 1 minus 125, so 122. So can we make smaller difference less than this using the other elements? So what can we do? Say for example, one general concept here is, okay, so if you want to move to the left, say for example, um, say as this is a sorted list, and any numbers previous to this would be lesser, and if you go with these numbers, the difference would be more. Similarly, if you are going afterwards, after the element after this, as this is a sorted list, and any number which is after this will be larger than this, so obviously the resultant difference would be larger. So instead of that, what we can do is, if the first element and this is there, so we can just move to the left. So that is what we can do for checking further. So if it is less, if it is 11, so we reduce from 122 to 116. So we reduce it this. So that's the main thing. So don't go this way or this way. Just come, like, move to the this to the right or move to the left. The resultant, the base case is, for example, if any two numbers we have chosen is equal, became coincidentally equal, so it would be obviously zero. So we can't get any difference less than zero. So zero is this is the best case of becoming equal. But if the two numbers are different, this is how it works. Okay. So initially we iterate. Um, so for example, we iterate through the list, like take the pointers at the starting elements and check. Okay, is 1 less than 8? Yes, true. So what you can do to minimize further the difference, you store the difference somewhere, 8 minus 1 7, as current difference, and you increment the first pointer. So 2 minus 8, it is 6, so you can still update, you can get lesser difference than this. So you try with the next element. Is 3 less than 8? Yes, so go subtract this, it will give 5 difference. Okay, so still 6 is bigger than the 5, so update the current difference with 5. So you will proceed further until there is an element greater than 8. Okay, so 5 is there and you will get the difference 3, and 11 is there. So yeah, when 11 is there, what will happen? 11 8. So 11 is greater than 8. So say for example, if there is any element next to 11 in the list, if you move that, as this is a sorted list, and the next element to the 11 would be definitely larger than the 11. So in that case, uh, there's no point moving to the next, this pointer to next, because this itself 11 and 8 is making some difference, and if you increase the first element, bigger element, it would definitely increase the resultant difference. So we not don't want to move this pointer anymore. So try to move the second pointer. So we got like 11 and 8. 11 and 8 is 3. So we stored that, but we don't know whether we can get smaller difference or may not be, because the next numbers cannot be are in a position to give the smaller difference. They might be larger numbers too, but in some cases it can be smaller. Say for example, here in this list 19 is there, but in some case, like say there is 9 is there, so 11 minus 9. So we got currently the difference of, hmm, say for example, yeah, 9 is there, so 11 minus 9 would give 2. So that's what I am trying to say. So move then the second pointer. Okay, so as like 11 minus 19 would give 9, still 3 is smaller, so no further going actually. So already we got the 11 and 8. 11 and 8 is the answer for this. We already got this, so this is the logic actually. So what we are doing with this procedure is, so we are st- like strategically moving further, instead of doing m into n times rotations in the for loops. Okay, so what is the time and space complexities? So time complexity is we are iterating through a loop and iterating through a loop, and we are finding the if conditions will be there. So it would be of big O of n, big O of n log n plus m log n. So one thing here is we are just iterating once, so it would be a bigger of n, but we are sorting before doing this. So each will cost n log n. Say for example, n is the first element length and m is the second element length. So n log n plus m log n. So we want to add that. So say for example, yeah. So finally, this is the time complexity for doing this logic implementation. And space complexity, we are just using pointers and we are not even building any new lists or something. We are just updating the actual answer, the resultant answer. So it is of big O of 1. So yeah, we can go to the actual implementation part. Say, so definition of smallest pair. This is, I will call something as array 1, array 2, array 2. Okay. So what we can do initially? So I will create these pointers indexes. We need to initialize some variables. That is, I will call index 1 is equal to 0, 0th index, index 2, the second list index as 0. These pointers we declared, and we need to create this, the smallest difference. Say I am just initializing the smallest difference to empty list, the resultant answer. This is list. And so yeah, this is, I will call this as a smallest pair, maybe. Pair is more suitable. So there is smallest. What is the smallest difference? Smallest difference is 3 in that case. So I will initialize with 0 because if there are no elements, it will be 0. Smallest. Or yeah, maybe yeah, smallest, and yeah, we will see what else. So start iterating for, so this is not, we knew the number of the iterations we do. This is not this fixed number of iterations, so we need to go with the while loop. We just need to check the pointers, the indices are less than the actual length. So while index 1 less than the length of the array 1, length of the array 1, and say these indexes should be both less than mm, their lengths. I mean, while iterations we will update these pointers, and sometime if the lengths crosses, the indexes crosses, so it shouldn't cross. So I'm just keeping that index 2 less than length of array 2. So this is the while loop. Okay, so we can initially check, or we can initially, what we can check here is the first element. is first number. I will just create a variable first number is equal to, so array1 of array1 with index id x1. The second number, I mean the number in the second list, which is appearing from array 2, take the index 2. Okay, so this first number and the second number. Compare these two numbers. If the first number, so there are two, like three cases. So less than, greater than, or equal to. So if the first number is less, what you will do? The first number is less. So as we talked, just we will calculate the difference, and we will store, we will increment the pointer. Say the current difference. Oh, I need to create the variable current. Current current is equal to current is equal to 0. I mean, sorry. So as we are trying to find the smallest. So if we give 0 here, it is already 0. It is already the smallest number. 0 is smallest number regarding the differences. So we need to create larger numbers. So we can, in Python, we can give float of inf, which would initiate these variables to the largest number infinity. Float of infinity. Okay, so we will check if the current, so we will current is equal to, what is this, second number minus first number. So we will store 8 minus 1 7 in the current variable. So what we can do, we need to further move this pointer by doing idx1 plus is equal to 1. Okay, so in case, else if, as we talked, less than or greater than, if the first number is greater than second number, what we need to do, we will still calculate the difference and store in the current. So first number minus second number, and in that case we need to increment the right pointer or the second pointer, idx2. idx2 plus is equal to 1. Okay, so we did this, and we need to actually write this. We need to compare the current and the smallest two. Current is something which we are getting in one iteration. Smallest, this smallest is for comparing with the next iterations. So second iteration comparison. So I will write that. So else if, so if else, if this is not, this is not. So we already, if it became equal, first number is equal to second number. So what is the minimum difference? If the two numbers are equal, 5 minus 5 0, which is already we got as uh, the smallest difference. So we can just return those two elements, return the first number and second number in your pair. Okay, so as I talked, we are doing current number in this iteration. For comparison, we need to compare if the current number, so is it like the smallest number. So what we're checking, we knew that there is a small number, but in this iteration, so we are updating the current number and we are checking. So is current number is less than the already known smallest number. In that case, what we need to do, you need to just update the smallest to the current. So in that case, we updated the smallest to the current. And we need to update the smallest pair too. So this will be continuation of this smallest pair. Smallest pair, we need to update it as the first number and the second number, which you are getting here. So yeah, so the first number and the second number, the first number and second number. Okay, so we in this check we are comparing, we are storing the small on the current in one iteration, the smallest number in the current, and comparing with the smallest and updating the smallest and the smallest pair. So after completion of this while loop, we will just return the just return this value, that is the smallest pair. We are already storing that in the smallest pair. So yeah, so this program will execute. Say for example, we are sorting, we need to actually sort here. So we need to sort that array1 dot sort, that's it, and array2 dot sort. This will come here. So we are sorting, which will execute in m log n and n log n. So this will execute in I think n times, that is whether if those are equal, it will execute, it is of big O of n times. So the final, the time complexity is big O of n log n plus m log n, and we are not storing anything here, so big O of 1. I think this completes the problem. Yeah.